we are going to study Newton's shell theorem for an object M that is kept outside a spherical shell. For the same, we have a spherical shell of mass M and an object with mass kept small m is kept at a distance r from the center of the spherical shell. Then we are required to calculate the force of attraction on this point on M by the spherical shell. Now for the same, we consider that there is a spherical shell whose mass is M, and let's consider an object with mass kept small m is kept at a distance, let's consider it's the center, is kept at a distance r from the point object, and we are required to calculate the force of attraction on this point M by the spherical shell that is kept outside it. Here we have that let's consider or divide this spherical shell into smaller sections and calculate the force of attraction that is applied by these small particles, these small parts of the spherical shell on this point. हम इसको काफ़ी सारे पॉइंट्स में डिवाइड कर लेंगे. उसके बाद छोटे से रीजन को देखेंगे कि वो कितना फोर्स लगा रहा है इस पॉइंट पे. We are just only going to calculate that, and let's the mass of this small area be dm. Now the distance between this small mass and this point, let's consider it's x. Then the force that this mass will apply on M would be df, because this mass is very small and the force it will apply obviously will be very small too. And the direction, obviously, as the force is attractive in nature, it's gonna be in this direction. Then we have now this force is a vector and it can be resolved into its components. One component would be like this and the other component would be like this. ऐसा क्यों? Because let the angle between the force and this direction be theta. Then this component is going to be df cos theta and this component is going to be df sin theta. Yes, the component जो theta के साथ होता है वो उसके साथ cos आता है cos theta, और जो नहीं होता उसके साथ आता है sin theta. Then we have another part, let's consider it's also dm. छोटा सा part ले लेंगे opposite to the first one that we took, and now let's calculate the force of attraction. This is also at a distance of x from M. Now the force of attraction it applies on M would be df, obviously, as it's very small. It also can be resolved, and the angle between this and this is theta. Then this force also can be resolved into two components, df sin theta and df cos theta. Now ये आप देखेंगे that for every point df sin theta and a point opposite to it, and the distance between them is going to be x. If it's taken x, then the force applied, the component that is df sin theta of this force and the component df sin theta of this force will be equal in magnitude, just because the distance is equal. And if they are equal in magnitude, and since you can see that these two components are opposite in direction, obviously they'll cancel out each other. ऐसा सिनेरियो हर पॉइंट के लिए होगा. जैसे ये dm लिया था, इसका डिस्टेंस x था, दूसरा dm लिया, उसका डिस्टेंस भी x था, उनका जो रेक्टेंगुलर कॉम्पोनेंट्स थे वो कैंसिल आउट हो गए. df sin theta वाले कॉम्पोनेंट्स कैंसिल आउट हो गए. अगर आप कोई और पॉइंट ले लेंगे dm here, another point dm here, that is at a distance y, both of them are at a distance y from this point, obviously their sin theta component will also get cancelled, just because they'll be equal in magnitude but opposite in direction. ऐसे ऐसे करते हुए you will see that सारे के सारे sin theta वाले components सभी applied by small parts of masses will get cancelled out. Only what would be left would be the cos theta component. Every part of the mass will apply a force, and its cos theta component only would be left. Sin theta component would be cancelled out, and all of them will have the df cos theta acting on the line joining M to the center. As all are acting in this line, along this line, all are in the same direction, will get added up. And when they will get added up, the force of attraction on M, on this M, by the spherical shell, the resultant of all these cos theta components that we will be getting would be G into M, that is the mass of the spherical shell, and M, mass of the point, and the distance between the center and R. That is obviously always going to be your result. So for an object that is kept outside the spherical shell, the force of attraction on this object by this spherical shell would be given by this formula. And secondly, we know that and for attraction, the force of attraction, if we have 2 points like M, the point is M, they're at a distance of R from each other, and the force of attraction between them would be given by Gmm upon R square. Force of attraction on this M by this point is given by this formula. It is in this direction. Here, this is the case if M mass is considered to be present all over. Next, if we compare this by this formula, we'll get that this is gonna be the case only if the whole mass of the spherical shell is supposed to be concentrated at the center. अगर सेंटर पे सारा का सारा मास supposed to be concentrated होगा, then only we can apply this formula. So इससे हमें दो चीज़ पता चली, that for an object placed outside the spherical shell, the force of attraction is given by this formula, and also the mass of the spherical shell is supposed, mark the word supposed, to be concentrated at the center of the spherical shell. Then this is all about Newton's shell theorem, and I hope you like my videos.